At first glance, it looks almost unreal. A massive warehouse where people are not loading pallets by hand, not walking endless aisles with clipboards, and not shouting over forklifts. Instead, thousands of robots glide across the floor in carefully choreographed patterns. Shelves seem to move on their own, and orders are packed with a speed that would have seemed impossible just a few years ago. This is the world of the most advanced robotic warehouse. And what makes it so fascinating is that it is not just a futuristic lab or a one-off experiment. This is real logistics at industrial scale. Every day, these facilities process enormous volumes of products, from books and household items to electronics and clothing, using a tightly integrated system of robots, software, sensors, conveyors, and human operators working together. The goal is simple in theory, but incredibly difficult in practice. Get the right item to the right customer as fast, accurately, and efficiently as possible. To understand why this matters, you have to understand how warehouses used to work. Traditional fulfillment centers depended heavily on human labor. Workers would walk long distances, search shelves, pick items, pack boxes, and move them through shipping zones. It was effective, but slow and physically demanding. If demand spiked, the system strained. If a product was misplaced, it could take time to find it. And as online shopping exploded, the old model started to hit its limits. That is where robotics changed everything. Modern robotic warehouses are built around one core idea. Instead of sending people to products, send products to people. This small shift has transformed the entire flow of logistics. Autonomous mobile robots can travel through warehouse floors carrying inventory shelves or packages. Robotic arms can pick, sort, and place items. Vision systems can identify products with remarkable precision. Artificial intelligence predicts demand, organizes inventory, and routes work where it needs to go. The result is a warehouse that feels less like a storage building and more like a living machine. One of the most impressive things about these facilities is how much coordination happens behind the scenes. Every robot, every package, every shelf movement is guided by software that constantly calculates routes, avoids collisions, balances workload, and reduces bottlenecks. Think of it as air traffic control, except that airplanes are thousands of robots moving across the floor and through sorting systems at the same time. The scale is staggering. In some advanced fulfillment centers, fleets of robots move across the warehouse floor in tightly packed traffic patterns, each one carrying a bin, a shelf, or a parcel. These machines can work continuously, only stopping for charging or maintenance. Some systems use QR codes, magnetic guides, LiDAR, or computer vision to navigate. Others rely on extremely precise localization software that allows them to know exactly where they are at all times. And unlike a human worker, a robot does not get tired after the 10th hour of a shift. But this does not mean humans have disappeared from the warehouse. In fact, one of the biggest misconceptions about robotic fulfillment is that it is fully automated. It is not. The most advanced warehouses are usually hybrid systems. People still inspect goods, handle exceptions, manage complex packing tasks, maintain the machines, and supervise operations. Human judgment remains essential, especially when dealing with damaged products, unusual shapes, fragile goods, or errors in the supply chain. What robotics has done is remove much of the repetitive, time-consuming, and physically exhausting work. Let's break down how a highly robotic warehouse actually operates. It usually starts the moment inventory enters the facility. Products are scanned, identified, and assigned to digital locations in the warehouse management system. The software does not just store the item's name. It tracks dimensions, weight, category, turnover rate, and where it should be placed for maximum efficiency. Fast-moving products are often stored in locations that are easier and faster to reach. Slower-moving items may be placed deeper in storage. Then robots take over. Autonomous robots transport storage units or bins to picking stations. At those stations, human workers or robotic arms retrieve the requested items. In some systems, goods-to-person fulfillment means the shelf comes to the worker, not the worker to the shelf. This dramatically reduces walking distance, which used to consume a huge amount of time in traditional warehouses. In fact, reducing walking alone can transform productivity, because a significant share of a warehouse worker's day once went into simply moving from one location to another. Once items are picked, they move to packing and sorting areas. Here, high-speed conveyor belts, robotic sorters, and machine vision systems help ensure each order goes to the correct destination. In highly automated operations, the package may be measured, weighed, labeled, and routed with very little manual intervention. The efficiency gains can be extraordinary. Some robotic warehouses are able to process orders faster, more accurately, and with less space than older facilities. Because robots can stack, shuttle, and organize inventory more densely, companies can often store more products in the same footprint. That matters in expensive urban or suburban logistics zones, where every square foot counts. But the most advanced robotic warehouses are not just about speed. They are also about data. Every motion generates information. Which items are ordered together? Which products are slowing down a line? Where do congestion points occur? Which robot battery cycles are most efficient? AI systems analyze all of this in real time. They can predict demand spikes, reroute robots to avoid jams, and even suggest better warehouse layouts based on usage patterns. This is one of the reasons robotic warehouses keep improving after they are built. They learn. Over time, the software can optimize slotting, meaning it can decide where products should be placed based on how frequently they are ordered. It can refine travel paths so robots spend less time in traffic. It can help managers identify issues before they become major problems. In other words, the warehouse is not a static building. It is a constantly adapting system. Another important factor is reliability. In traditional logistics, a sudden labor shortage, shift disruption, or seasonal rush could cause major delays. Robotic systems offer a more stable operational backbone. They can scale quickly by adding more robots or extending operating hours. During peak periods, that flexibility becomes a massive advantage. Of course, robotics also introduces new challenges. These systems are expensive to build and maintain. The software has to be exceptionally robust. Integration with existing supply chains can be complex. And the warehouse still needs people who understand automation, mechatronics, sensor systems, and data analytics. In many ways, robotic warehouses are creating new kinds of jobs while reducing others. Instead of spending all day walking and lifting, workers increasingly supervise machines, troubleshoot equipment, and manage automated workflows. That shift is important. The warehouse of the future is not simply robots instead of humans. It is a collaboration between human adaptability and machine precision. One fascinating example of this collaboration is the robotic arm. In the past, robots were great at repetitive industrial tasks in controlled environments, like car manufacturing, where every part was predictable. But warehouses are harder. Objects vary in shape, texture, size, and packaging. A robotic arm has to recognize items that may be shiny, soft, reflective, oddly shaped, or partially hidden. To solve that, advanced warehouses use machine vision and AI-powered grasping algorithms. Cameras and sensors help the robot identify an object, estimate how to grip it, and place it correctly. The robot may analyze thousands of possibilities before selecting the best motion. This is a major technical leap from older factory robots that perform the same exact motion over and over. Another innovation is the use of autonomous mobile robots, or AMRs. These are not the same as old-style automated guided vehicles that followed fixed routes. AMRs can navigate dynamically. If a path is blocked, they can reroute themselves. If traffic increases, they can adapt. This makes the warehouse more flexible and resilient. Some robotic warehouses also use vertical storage systems, where inventory is stacked efficiently and retrieved by machines that travel upward and downward with precision. This allows companies to make use of height, not just floor space. In cities where land is costly, that vertical efficiency is incredibly valuable. The robotics ecosystem also includes packing automation, which is often overlooked but extremely important. Packing is not just putting an item in a box. It involves selecting the right-sized package, protecting fragile products, reducing wasted material, and optimizing shipping weight. Some advanced systems can create custom-sized boxes on the fly, reducing excess air and lowering shipping costs. That also helps with sustainability, because less packaging material means less waste. And sustainability is becoming a bigger part of the story. Because robotic warehouses are often designed for efficiency, they can reduce unnecessary movement, lower energy use in certain operations, and improve space utilization. Better inventory placement can reduce truck congestion and storage waste. Custom packing can reduce material consumption. At the same time, these systems do require substantial electricity and sophisticated equipment, so sustainability depends on how the whole operation is designed and powered. There is also a human story inside these warehouses that is easy to miss. For employees, working alongside robots can change the nature of the job. It can mean less physical strain, fewer miles walked each shift, and more focus on monitoring and problem solving. But it also requires training and adaptation. Workers need to understand safety protocols, system alerts, equipment interfaces, and quality checks. The warehouse becomes less about brute force and more about technical coordination. Safety is another major issue. When robots and humans share space, the warehouse must be engineered carefully. Sensors, barriers, emergency stop systems, and traffic rules are essential. The software must prevent collisions and manage interactions between moving machines and people. In the best systems, safety is designed into the architecture from the beginning. What makes all of this so remarkable is how quickly the transformation has happened. Not long ago, robotic fulfillment sounded like something reserved for science fiction. Today, it is a key part of the logistics infrastructure that supports modern e-commerce. When someone clicks buy now, there is a good chance that the item will pass through a highly automated system before it reaches the doorstep. That means the robotic warehouse is not just a technological curiosity. It is the hidden engine behind the convenience people now expect. And the most advanced facilities are still evolving. Researchers and engineers are working on better dexterity for robotic arms, smarter AI for inventory forecasting, more efficient battery systems, and improved coordination across fleets of hundreds or even thousands of machines. The next generation may include even more adaptive robots, deeper automation, and warehouses that can reconfigure themselves in response to demand. Imagine a facility where robots not only move goods, but also monitor stock levels, predict shortages, optimize packaging, and collaborate with humans in real time across every step of the fulfillment chain. That future is already starting to take shape. So when we talk about the world's most advanced robotic warehouse, we are really talking about a new model of industrial intelligence. It is a place where physical movement and digital decision-making merge, where speed meets precision, where software turns square footage into throughput, and where robots are no longer just assistants, but essential parts of the supply chain. It is easy to look at these warehouses and focus only on the machines. But the bigger story is what the machines represent, a complete redesign of how goods move through the modern world. From the outside, it may look like a giant building full of shelves and steel, but inside, it is a coordinated ecosystem of sensors, code, data, and motion. A place where every second counts, every route matters, and every item is part of an intricate choreography. And that is what makes the robotic warehouse so powerful. It is not simply replacing old labor with shiny technology. It is creating a smarter, faster, and more responsive way to handle the enormous demands of global commerce. The next time a package arrives at your door sooner than expected, there is a good chance a robotic warehouse played a role in making that happen. If you enjoyed this deep dive into the world's most advanced robotic warehouse, subscribe for more facts, technology stories, and behind-the-scenes looks at the systems shaping our future.